I'll be honest, I feel like this should be slightly later on in the paper. Like, I looked at this for a while and I thought, how on earth am I going to find it? We've got A, B, C as a three-digit number. Now, because we're doing the products of the digits, we can in fact ignore zero. So there's going to be nine possibilities for A, nine for B, and nine for C. There's going to be 729 possibilities. That seems a lot. We don't want to be writing all of them down. So let's just start it off. That's what I decided to do. I decided to write down, let's go with A equaling 1. So I've got 111 and then 112 and then 113. I'm just writing them as a list. And I went up to 119 and I just sort of had a look at what's going on there. So it's going to be 1 times 1 times 1 plus 1 times 1 times 2 plus 1 times 1 times 3 and 1 times 1 times 9. If I then carry it on, so I can ignore 120, but do 121, 122, and so on up to 129. It's going to be 1 times 2 times 1 is 1 times 2 times 2, 1 times 2 times 9. And we can see there's something going on here actually, because if I was to carry it on, then I could factorize and add all of these together, this, and the next one. I've got this common factor of 1 that I can actually take out. So then I've got 1 times 1. I'm just dealing with this bit to start with. 1 times 1 plus 1 times 2, all the way up to 1 times 9. And then it would be 2 times 1 plus 2 times 2, all the way up to 2 times 9. And it would carry on in this way. So I'm doing 9 times 1. This is for 191, plus 9 times 2 for 192, all the way up to 9 times 9. I'm only dealing with A equals 1 for this moment. Let's just be clear of that. But what we have again is I can factorize out the 1 in the middle bit. So I've got 1, and then it would be 1 times 1 plus 2 all the way up to 9, plus 2 times 1 plus 2 all the way up to 9, and so on. 9 times 1 plus 2 all the way up to 9. That is me actually adding up the product of the digits of all the numbers from 111 to 199. And we can actually, there's a common factor of this. So in fact, it becomes 1 times 1 plus 2 all the way up to 9 times that again. And finally, if we do it for not just all the numbers where A is 1, but with 2, I'd get the same thing with 2, but I just have a 2 here. And then the same with 3. I'm actually going to get 1 plus 2 all the way up to 9. The answer just comes out to be really nice, times 1 plus 2 all the way up to 9. And finally, this. So it's in fact this cubed, sorry, which becomes, if you add them all up, 45. You can do it by hand, or you can do a half n plus 1 when you're adding the numbers from 1 to n. So a half times 9 times 10. That's 5 times 9 or 45. 45 cubed, which is going to be, wait, how are we asked to leave it? I think maybe that's actually in the answer. So our answer ends up being C. So when you look at this question, you think, how on earth would I even begin? The answer is just begin. Just start it off by adding some of them together and look for some patterns. It's got to be like the answers are all relatively like nice in the grand scheme of things in terms of powers. It's not just some like really big number that we can't even relate to. They've written them in powers. And so you just got to, I mean, I'm not saying you would do it exactly like I did it, but just get it started and see if you can spot how it all connects together. The answers, see, I wouldn't necessarily just do this to fix A and B, but that's what they do. They fix A and B, and then they kind of just do the sum of the product of the digits to get that first 45, and then they fix B, and then they fix A in a similar sort of way. That's their explanation, but it doesn't quite feel as natural as when you're trying it out So I'm just going to very quickly talk about it again. Actually, this was a bit of a red herring. I mean, it's what I did when I did the question, but it's not going to be that important in the long run. Just started off by doing 111 up to 119. Those are our first numbers that we can include that don't have a digit of 0. Have the product and then look for common factors. So there's that common factor of 1, which is why I took it out. Later, I think I took it out down here, and then I saw another um, well, not, oh, sorry, I did the same for 121, had that same common factor of 1, which I took out of all of it. I kind of ended up with this, and then I saw these patterns going on, um, that we could just have one lot of this and two lots of this, and then brought all of that together. And finally, just thought, what happens when I vary A as well? I'm going to get an extra, it's going to be adding all of these together, one lot of this plus two lots of this plus 3, all the way down to 9. So I could bring it together like this, and then it all came together as 45 cubed. I don't know. That's my best explanation. Hopefully you're happy with that. I think it's you can just look at that question and think, I have no idea where even to begin, but the answer is just begin. Just see where you can get to. That's half the battle often with these maths questions. Like once you're on the right path, it kind of comes together. And a question that looks impossible actually turns out to be not so impossible. That is our answer, 45 cubed. Anyway, well done on your efforts here.